Hi, in this Shader Stories series, we're looking at visualizing the Mandelbrot set. In the first two parts, we displayed the Mandelbrot in grayscale with a compute shader and enabled you to navigate around it. In this episode, we'll add the ability to color it using arbitrary gradients. Let's get started. We're going to want to be able to set the gradient used within the compute shader from the Unity inspector. In our shader display script, we're going to add a new private serialized field of type gradient called gradient. This will be our Unity object that allows us to set the colors we want to use. We are also going to need a way of getting this to the compute shader. For simplicity, we're going to pass a texture 2D to the compute shader with the gradient in it. So we add a new private texture 2D called gradient texture. Now we have those variables, we can modify our update render texture method to pass them to the compute shader. As with the render texture we used, the gradient texture will not start initialized. So if the gradient texture is null, then we create a new gradient texture. The dimensions of this will be iterations per group in the X and 1 in the Y. So if our iterations per group is 256, we'll have a 256 by 1 texture with our gradient in it. There is another time we will want to update our gradient texture. This is when the iterations per group changes, as that will change the size of the gradient. We add this in to our statement by saying if iterations per group is not equal to the current gradient texture width, then we know it's changed and we need to update it. Now we've made sure our gradient texture has been created the right size, we need to update it. So after this, we add a call to update gradients. And we'll create that function now. We want to take our gradient and map it to our, say, 256 values in the gradient texture so they can be used in the shader. To do this, we'll use a for loop. From I equals 0 and carry on while I is less than iterations per group. How far we are through the gradient as a 0 to 1 value is going to be I as a float so it doesn't get truncated integer division, divided by iterations per group minus 1. Now we have that, we can use the setPixel method on the texture 2D. This takes three parameters. The first two are our X and Y coordinates. So that is I for the X direction and just hard-coded 1 for the Y. It's only one row of pixels we need to do. The third parameter is the color, and we get this from our gradient object by using the method evaluate and passing in %. This will tell us what color the gradient is at that part through. Once we have set all the pixels in the for loop, we call apply on the gradient texture to save this. So we've created the gradient texture, now we need to pass it to the compute shader so it can use it. In our update render texture function, after we've set the num iterations per group and num groups, we'll add another call. Compute shader.setTexture. This takes in the kernel as the first parameter, which we just called kernel. Then the name of the variable we're passing. Again, I'm just using the snake case name of the object in the shader. Now we need to jump over into the Mandelbrot shader code to consume this new texture we've just added. To do this, we simply add our gradient texture variable, which takes the type of a float for texture 2D. And now we've got the gradient data passed from Unity into the shader, we can jump into the Mandelbrot function and consume it. Rather than trying to edit things in line, we'll just simply delete the calculation of the grayscale and outputting the results, and we'll recreate it. This time, we're returning a gradient position based on the number of iterations to calculate if the point is in the Mandelbrot. We have a uint gradient pos, which is simply the iterations for exclusion taken modulo the iterations per group. So this will be a number between 0 and iterations per group minus 1, which is exactly how many points we have in our gradient texture to pick from, so that's nice. Like with the grayscale, we'll flip the gradient for each group so we get a nice continuation of colours. So again, we'll have a uint isOddGroup, which is the integer division of iterations for exclusion over iterations per group taken mod 2. So that'll be 0 until the number of iterations we have taken reaches iterations per group, in which point we'll switch to a 1 to indicate it's an odd group. Now we can update the gradient pos. If it is an odd group, then we need to invert the gradient pos. As this is a number going to iterations per group minus 1, we just need to subtract the gradient pos from this. else we just take the gradient pos as it is. As I explained in the previous video, the use of the ternary operator here just saves the need for branching. We could stop there, but I want to special case the final shade as before. So if iterations for exclusion matches total iterations, then we'll just set the gradient pos to 0, else we'll leave it alone. Awesome, now we have a gradient pos, so how do we extract the colour from the texture to put into our result? For this, we use gradient texture.load. For a texture 2D, this function takes an int3 parameter. The first two parts are the x and y coordinates of the texture, which will be gradient pos and 0 for us. Remember, these are 0 up, not 1 up. The third is the mipmap level, so we can just pass in 0 there. That should be it. As an exercise for yourself, perhaps you want to pass the final colour value in as a parameter, then you can have it to be anything you like. Let's jump back into Unity and check this out. We can see that we now have a gradient picker in our inspector. This starts out as a plain white, which isn't very appealing. So let's click on it to open the gradient editor and make something more interesting. Hopefully you've seen this before. The tags on the top are for setting the alpha. We're not using any transparency, so we can just leave those alone. The bottom ones are for setting the colour. If you click on them, then you can set the options in the colour picker, and then you can click to add more. Here I'm adding a black to blue to white gradient. If you click on New Preset at the bottom, it will save your gradient so you can easily swap between them. You can see I have a rainbow one I created earlier, so let's pick that to start with. Hit play. We've got this set at 256 iterations per group, so it's quite hard to see the detail when we're zoomed out this much. But we can reduce this back down to 32, which works nicely to help see what's going on. We'll zoom in towards the Seahorse Valley. Upping our number of groups to 2, we can see the rainbow repeating. Now we've zoomed in, we could increase the number of iterations to get smoother colour changes. It's really cool seeing this all update in real time. Though I have to say this rainbow pattern is a bit garish. Let's swap out our gradient to the black to blue to white one. I like that much better. Reminds me of a starry sky. Feel free to take a look around, play with the settings and see what cool images you can discover. That's it for this episode. There's more I want to do in this series, specifically improving the code so we have double precision, which will enable us to get better control as we zoom in further. But I'm going to take a little break from this niche topic and pivot back to the Let's Create series for a bit. As ever, the full code is on GitHub and linked in the description below. See you next time.